Diagrammatic representation of a solution of an algorithm can also be helpful for us in order to have a better way of communication of a logic of a program. While doing a system analysis or a program development phase, this flowchart will going to help us as a guide or a blueprint. Just by looking into that, we will be able to do the coding or a programming. In order to represent the beginning, end or a point of the interruption in a program, then we are going to use this symbol called terminal. Everybody, a warm welcome to one and all. Welcome to the last session of this unit 1 in the B.Ca's first semester subject called Fundamentals of Computers. I am Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So before getting into our today's session, we'll just have a quick recap of our previous session. As we all know that in the last session of this unit, we had a discussion regarding language translators. In that language translator, we have a assembler, compiler and then interpreter. And also we had a discussion regarding what you mean by linker and what is loader. And also we started with programming a computer. In that we got to know what is algorithm and also have discussed what are the characteristics of algorithm we have along with an example. So we'll continue with the algorithm. After that we have a flowcharts here. So in the today's session we're going to learn about this flowchart, what is its importance and what are the symbols we have in it, and we'll see some of the examples, and at last we're going to learn about this pseudo code. This is all regarding our today's agenda. Let me get into our today's session. That's all regarding flowcharts here. Already you know, algorithm is a step-by-step procedure to solve a given problem. So whenever we have that algorithm, that should be represented in some diagrammatic representation way, then we are calling that as what? Flowchart. So as we all know that one image is equal to 1000 words. Instead of saying about particular incident or scenario, if we have a video or image of that particular scenario, that would be easier in order to understand. In the same way here, a flowchart is a pictorial or a graphical representation of an algorithm. We are representing an algorithm in the terms of diagrammatic or pictorial representation, and also this will going to play a very important role in order to write the solution of a particular problem, and it is easy to understand a logic of a program. Why? Because it will be in some diagrammatic or a pictorial representation. So once the flowchart is drawn, then we can convert that into any of the programming languages. Then what are the types we have? It got classified into two categories. One is program flowchart and another one is system flowchart. For example, if I have a program or if I have a particular system, consider this is whole system. In that we have a different program. So this program flowchart will going to specify the flow of a data in a particular program sequence, but system program will going to specify the flowchart of a whole system or a whole program here. So flowchart of this first type, there we have a program flowchart. It represents a diagrammatic representation of a sequence of instruction for solving a problem or a solving a program. So in this will going to specify a sequence one after another. First I am taking a start, then I am taking a reading or taking an input for some of the variables, then we are calculating after printing, then stop. That is what it is showcasing, the sequence of instruction in order to solve a problem. And then we have a system flowchart. In this system flowchart, it will going to indicate the flow of a data throughout a data processing system, as well as the flow into and out of the system. What is the input we are taking, what will be the output, how it is flowing throughout all the processing of that data, from the time of taking input at the time of giving output. Throughout that processing will going to be represented with the help of this system flowchart. These are the types of flowchart we have. Next, here you can see what is the importance of a flowchart, then how it is helpful for us. In that, first what we have, communication. So as I told earlier, one image is equal to 1000 words. So this diagrammatic representation of a solution of an algorithm can also be helpful for us in order to have a better way of communication of a logic of a program. So it is going to helpful for us in order to get to know the logic of a program. And also effective analysis. So with this diagrammatic or a pictorial representation, this will going to helpful for us in order problem can be analyzed in more effective way. That's why we are calling this as a effective analysis. This flowchart will going to give us effective analysis of a problem, and also proper documentation. With the help of this program flowchart, that will going to serve as a good program documentation which is needed for various programs. So whenever we are writing a flowchart for a particular problem, or whenever we are writing a flowchart in order to solve a particular problem, that doesn't mean only for that problem. So you can use it even in the future. That is why this proper documentation with the help of this flowchart can be maintained very well. And also efficient coding with the help of this flowchart. After looking into that flowchart, we will be able to write a program. So that will going to act as a guide or a blueprint. So while doing a system analysis or a program development phase, this flowchart will going to help us as a guide or a blueprint. Just by looking into that, we will be able to do the coding or a programming. And also proper debugging. This flowchart helps in debugging process. Why? Because it will going to specify each step in a diagrammatic representation. Wherever we are getting an error, that will be easy by making use of, or finding of that errors will be easy by making use of this flowchart. And also efficient program maintenance. So here the maintenance of a program become easy with the help of this flowchart. All these benefits we can get with the help of this flowchart. Then we can also say that as a importance of a flowchart. I hope you all understood regarding this. Then what are the different symbols we have in a flowchart? How it is going to be represented diagrammatically? Here we have a set of symbols that will going to be helpful for us in order to write a flowchart. So first you can see the terminal. So already you know about the start, stop and calculation, taking input, representing the output. So that and all you know, right? So in order to have a start or stop, in order to represent the beginning, end or a point of the interruption in a program, then we are going to use this symbol called terminal. Then what about this input or output? In order to take a input or output, we are going to use this parallelogram. This is oval and this is parallelogram. That will going to helpful for us in order to take the input or output data or any of the information. Next here we have a rectangle that is mainly used for the purpose of processing or for calculation. So processing an instruction or a group of instruction which changes the program. So that is what going to act as a core of a program. So this rectangle shape will be used in order to do the processing or in order to do the calculation part. Next we have a preparation. Mainly we are going to use this hexagonal mainly for the purpose of looping. So when we wanted to repeat a set of statement again and again until that condition become false, then we are going to use this looping symbol here. A set of instruction that is repeated as long as criterion holds. So in order to have a looping criteria in our program, then we have to use this symbol. Next here we have a rhombus that is mainly for the purpose of decision making or a branching. So when we wanted to choose in between the choices whether true or false, if A is greater than B, yes or no, then at that time we are going to use this decision making or a branching symbol, that is rhombus, that represents a comparison. As I told, A greater than B, that greater than symbol is comparison, relational operator. In order to have that, we are going to use this rhombus, and to perform a question or a decision, that will going to determine the alternative path which to be followed. So here, in order to represent alternative path, whether true or false, in order to have all those kind of things, we have this rhombus here. And next we have a predefined process, a group of operation not detailed in the particular set of flowchart. So this will going to act as a sub-program. Next we have a connector. I had written some flowchart here. I wanted to go to next page. Then I have to use this connector in order to connect the disconnected flowchart to another one flowchart. So an entry from or an exit to the another part of a program flowchart in order to merge one or more flowchart, or in order to establish a connection between the different flowchart, we have this connector here, and then we have a flow direction to showcase the direction of a processing or data flow. Then we have to use this direction or a flow direction symbols. By making use of all these symbols, we can get the benefit of this flowchart, which is a diagrammatic or a pictorial representation of a solution of a given problem. We'll see the example with respect to the flowchart now. So here first we have to write an algorithm. That algorithm will be converted into its flowchart. Fine. So what is problem we have? Design an algorithm and flowchart to find the area and circumference of a circle. Before that, you have to analyze. What is the question here? Finding an area and circumference. How we are going to find an area? That is pi r square, isn't it? That is in order to find the area of a circle. And how we are going to find the circumference? That is 2 pi r. This is for area of a circle and this is for circumference. This is what I got to know by analysis. Then what must be the input? Already this pi is standard unit, 2 is standard unit or a value. Then we have to take a value for radius, that is r. We'll start with the first step, start. So if the first step is start in the algorithm, then how it will going to be designed, or it will be written in the flowchart with the help of terminal. Within that you have to write, that is start. Then I am giving a flow direction towards the bottom, that is down. Next step 2, input rad. So that r represents the radius here. So I can take rad, or else if I am using r, wherever I have rad, that should be written as a r. So if you are using radius, whatever could be the variable that you are declaring, that should be same throughout your algorithm and flowchart. So how we are going to take a input in this? That is by making use of parallelogram. So in that we have to write input rad. So next is important, that is step 3 related to calculation, area and circumference. How we are going to write an area? Pi r square. Pi value is 3.142 into. So here that represents the product, into we are going to use ampersand, 3.142 into, that represent the asterisk symbol rad, that is pi r square. R square in the sense r into r, that is rad into rad. Then how we are going to find the circumference? That is 2 pi r, right? So 2 into pi value is 3.142 into r is radius here. After that we have to display the output. So for that, output area, comma, I am displaying two values here. One is area and another one is circumference. So the variable name, however you use, that should be same at the time of declaration of output. Output area, comma, circum. So here also you can see, for the calculation purpose, we are going to use this rectangle symbol that shows the processing. Area is equal to pi r square and circumference is equal to 2 pi r. So once the calculation is done, then we have to display the resultant. What and all I am displaying? Output area, comma, circumference. Once we got the output, at the last step we have to stop. In order to stop that, we have a terminal here. With the help of this terminal, we can stop this. This is how we are going to write or design a flow chart along with the algorithm. We'll see one more example, that is to find the largest of two numbers. I have two numbers called a and b. Amongst that, which is the largest, that we are finding. Fine. So in this first step is what? Start. So here also you can see we have a terminal called start. After that, step 2, input a and b. We have to take two values a and b in order to find the largest of two numbers. Ma'am, can we take m and n? Yes, you can take m and n. Whatever the variable you wanted to take, you can take. But throughout the program or throughout the algorithm, you have to use the same. Fine. For input a and b, I am taking a parallelogram, input a, comma, b. After that, we have a calculation. So in that, I am making one checking of a condition, or I am making a branching or decision making. If a greater than b, if a is greater than b, if a is 10, b is 20, is a is greater than b, is 10 is greater than 20? No, right? At that time, this will comes to the else part. So if a is 20 and b is 10, at that time it will be like, is 20 is greater than 10. True or false? It will be true. Why? Because 20 is greater than 10. So at that time, if part will going to execute. If the condition is false, then else part will going to execute. Okay, see here, if a greater than b, if it is true, then output a. Otherwise, else we have to output the b. How we are going to write that then? By making use of this rhombus or a decision making. We have to use a keyword called is. We are checking, is it, right? That is a greater than b? Question mark. If it is true, then we have to output A. If A is greater than B, then the largest is A. Else, or a false statement, output B. If the condition is true, then output A. If the condition is false, output will be B. Whether it is A or B, we have to end the if statement. So here we are ending the if statement. Whether output is A or B, we have to end that statement. Then at last we have to do the stop. So this stop will be represented with a terminal. Right? This is how we are going to write or to design any of the algorithm along with a flowchart. First, you need to analyze what is the problem, then what must be the input, how we are going to calculate, then what will be the output. At last, don't forget to write the start and stop. I hope you all understood regarding this designing an algorithm and flowchart. So next we'll go with the next concept. That's all regarding pseudocode. So we got to know algorithm, flowchart. Algorithm is a step-by-step procedure and flowchart is a diagrammatic representation. What is the interface in between algorithm and flowchart? That's all regarding this pseudocode. It is also a technique which is used to describe the distinct steps of an algorithm. This is showcasing the distinct steps of an algorithm in an easier manner, which will be easy to understand for anybody with a basic programming knowledge, and also mainly this is a syntax free description of a algorithm. So there no need to use any of the step 1, step 2, step 3 like that. So with the help of some construct, we can represent the pseudocode here, and mainly this is an abstract representation of a program in English statement. So here you can see that starting of a program and taking an input. So without any syntax or without following any of the set of rules and regulation, we can describe the algorithm in the English language. Then we are calling that as a pseudocode here, and in pseudocode English words and phrases are used in order to represent the operations. Then what are the different constructs can be represented by making use of this pseudocode? Mainly it has the ability to represent 6 kind of programming construct, and we have to write always in a uppercase, and that include sequence, one instruction after another instruction, and that specifies the case. So when we have to make a choice amongst the different choices, at that time we are going to use this case. In the switch case we can use it, and while. So in order to check the condition priorly, then we have to use this while, and we have a repeat until, and also we have a for loop. When we have a fixed number of repetition, at the time we have to use this for loop, and if then else. If this condition is true, then that will going to be followed or happen. That is if then else. So all these 6 programming construct can be represented with the help of this pseudocode, and also we are calling all these construct as a keywords. Mainly it is used to describe the control flow of an algorithm. By making use of all these control flow, we can represent the algorithm by making use of a English and other phrases here. So you got to know the basics of this pseudocode. Here you can see the example. Mainly we are calculating a average of 5 numbers here. This is not looking like an algorithm. Even it's neither algorithm nor flowchart. So just by using simple words and phrases, we are writing a algorithm start, and we are inputting 5 numbers and store them in the variables. That numbers can be num1, num2, num3, num4 and num5. Then what we are doing, we are calculating the sum of 5 inputted numbers, and then we have to store them in a variable called sum. I am taking 5 numbers, I am storing that in the variable called sum. After finding the sum, that should be divided by 5. Why? Because we are finding the average of 5 numbers. So what we have to do? Again we have to do the calculation of average of 5 inputted numbers and store them in the variable called average or AVG. Then we have to print the value of a variable average or AVG. How we are going to find the average? AVG is equal to sum divided by 5. So this is the formula to find the average that we are not showcasing in the pseudocode. We are not letting the logic to be exposed here, and at last we have to end. Okay, somehow it is slightly different than the algorithm. This is how the example of pseudocode look like. Then what are the advantages we can expect from this pseudocode? It is easy to read. Why? Because it is in the English language, and moreover it is very understandable form and easy to modify, and also mainly it is easier to read, and it simplifies the code construction. No need to worry about the number of steps and all, so that will be easy for the construction, and it is a good middle point between the flowchart and a code. So after the flowchart you can have a pseudo code that will going to help the programmer to write a code in a very efficient manner, and also it is a helpful starting point for documentation. Why? Because somehow it is in English phrases and all, it will be acting as a documentation also, or document as well. So that's why somehow it is helpful, and also it is allows for quick bug detection. We can easily get to know what is the error that we have in it. So it's all regarding advantages of pseudocode. By this, we are at the end of this session as well as the unit. So in my coming session, we're going to see this unit 2. That's all regarding anatomy of computer. Let me meet you in the next session with a new unit. Until that, keep learning, keep on growing. Thank you.